Jansi was there.
Yeah, I think we can start now. Am I audible? Can someone please confirm? Uh,
Yes, sir.
okay, thanks. So I already have a query that in week 2 there is no 32 present in the question 4. So there are, I think the solutions are released for the assignment 0, 1 and 2. So have you gone through those solutions, Jay?
Yes, sir.
Okay, so mm, so what you can do is reporting. You can mail to the NPTEL team. I think there is a forum in the website itself where you submit your assignments. So there is a NPTEL forum where you can post your doubts to the professor directly. So maybe you can post that the solution or the final answer is not matching any option, and they will take the necessary action. Yeah, thanks. So yeah, welcome everyone. Welcome to the live session for the course Digital Circuits Week 3, which is taught by Professor Shantanu Chattopadhyay, and I am Anant Singhal, a PhD student from IIT Jodhpur. And today we'll be solving some of the similar assignment problems that have been given to you in the week 3 that will help you gain more clarity and some of the concepts that you might have not covered in your theoretical lectures. And with that, since we have already covered the basics of this particular course, that is a Boolean algebra and some of the introductory part, now we'll be going towards some of the minimization techniques that we can use instead of using the direct quantities or the direct formulas. We can directly use some of the minimization techniques and uh, minimize the Boolean expression basically. So yeah, so if I go, so is there any query? Someone has raised their hand. Before starting, if is there any query, please let me know quickly. Otherwise, we can go to the or we can start the session. Okay, so I'm assuming there are no queries, then it's fine. Oops. Yeah. Okay, fine. P by QS. Okay, what do you mean by P by QS? And again, someone has raised their hand. Previous year. Okay. Okay, I'm not sure about that. Maybe I'll take a look if it is possible to get the previous year question papers. Maybe you can try searching on Google if it is there, but I'm not sure, completely sure about it, if they release the question papers or not. Okay. Arpan, what is your doubt? Okay. I think it's not. Is Moni, what is your doubt? Uh, is Sunitha is, are you there? So all of you who have raised their hands, I'm assuming that you all have some doubts, right? Uday, Shri and Mithri or Maitri. So if you have any doubts and if you're not responding, please type in the chat box. I'll try to cover the doubts while in between the session. Till then, we can start the session. Yeah, so I was going through the course outline. We have already covered the introduction and the Boolean algebra part, and today we'll be focusing on some of the function minimization techniques, which are some of the techniques that are K-map and some of the Boolean identities we have already covered in the previous lecture, like some of the basic theorems such as distributive and others, De Morgan's, etc. But yeah, so this is a main technique actually, the K-map or the Karnaugh map. You might have already gone through the lectures. Okay, give me a moment. Yeah. So you might have already gone through the lectures by Professor Chattopadhyay, and this is a very important technique that you should be knowing to minimize any Boolean expression because it is very helpful and it is very easy to understand also. And the basic, I would say the objective of minimizing is to reduce the cost, right? Ultimately, what we are doing is we are trying to make some of the logics that we are trying to place in our circuits, or what we are trying to make is a logic gates. So whatever the expression that we have, if we minimize that expression, the cost of the gates will get severely minimized, and that is what we want, right? We want to have a minimum cost devices in our hands. So yeah, so we'll be going through mainly through the K-map technique for this particular lecture, and we'll be solving some of the problems that are related to week 3 assignments. I think this is enough, and now we can start. Okay, so the first problem is which of the following. So those who are raising their hands, I'm again asking you to type your queries in the chat box. I'll try to cover them while in between the question and sessions. Yeah. So the first question is which of the following is the correct simplification of the function. So there is a function given by PQRS, which is PQS P bar R bar S bar, then P bar Q P bar S P bar R S bar, and then PQ bar S bar. So there are in total 5 terms here, and it says what is the correct simplification. So by simplification, they are meaning nothing but minimization of this function only. So we need to minimize this function and see what is the simplified version of this particular problem. So maybe for the first time, let me do the one problem by using K-map. I think that you are already aware of the K-map minimization, so you can also do this particular problem in your uh, with till I am doing this problem. You can also give it a try, and you can type your answers in the chat box. And those who don't know what is exactly the K-map, let's do that problem once. So let me rewrite this. The function which is given by PQRS is given, which is PQS plus PRS. Okay, all the bars are there. Then P bar Q, then P bar R S bar, then P Q bar S bar. So yeah, this is the function, and we need to minimize this. So since this lecture revolves around the K-map, so we'll do the same and we'll make a K-map of this. So since we have 4 variables, so we'll make us 16 combination K-map that will be involving starting from P bar Q bar, P bar Q, PQ, PQ bar, then sorry, R bar, S bar, R bar S, RS, and then RS bar. So this is nothing but 0, 1, then 2, 3 comes here. I hope you already know this numbering. 6, 7, then here it is 8, 9, 10, 11, then it's 12, 13, 14, 15. So this is how basically we represent a K-map. And sir, option, sorry. Oh, you want to see the option? Okay, yeah, let me show you. Yeah, this is fine. So
Sir,
yes.
sir, that you have right now, sir. Can we write PQ on top and RS on down, sir?
Oh, okay, yeah, that is a good doubt. So actually, you have to write. So since this is from where the zeroth starting happens, and this is, so these are nothing but numbers, right? So since your question states the order of the problem, right? Whatever the function. So if here it is written as R, S, Q, P, or whatever, so you have to start from R and you have to end it with P. Now since the question is stating you have to go P, Q, R, S, so you have to write it like this only. because the first number that you see is bar means 0, right? So the first number will be 0 0 and then 0 0. Then the second number will be 0 0 and r bar s means 0 1. So that is how these combinations are being made. If you just replace that, let's say if you have written r bar s bar here and for example p bar q here, so this number would have become 0 0 and then 1 0, right? I mean, sorry, not 1 0, but 1 0 0 0. That is not correct. Or 0 1 0 0, my bad, because the function has to be written in the order of PQRS. Now, if you have written this as R bar S bar, so this will be 0 0. And since you have written this as P bar Q, so it will be 0 1, which is a representation of 4 in binary. But here it is actually 1, right? So the order should always be like this, whatever the question has demanded. Is it clear?
Yes, sir.
Oh,
सर
yes.
सर जस्ट लाइक जैसे आपने 0 1 3 2 लिखा है तो इसका ऐसे होना चाहिए ना 0 1 2 3 4 5 6 7 6 को आगे पीछे कर दिया क्यों ये
Yeah.
ऐसा क्यों किया आपने
So yeah, so there is a reason for that too. So in general, what happens is the K map that we write, it is in a form of gray code. So gray code is a one more version of a binary representation that we'll be seeing somewhere in some of the lectures. So gray code, what gray code is, it involves the transitioning of a single bit from the previous bit. For example, let me give you example. So let's say 1 2 3 4 only. So in binary we write one as 0 0 0 1. Okay, let me start with a 0. Then in 2 we write 0 0 1 0, and 3 we write 0 0 1 1. I hope it makes sense. So now, yeah, I'm trying to tell you what is the gray code. So this is a binary representation, right? So what we want exactly is the minimum change. So whoever has opened their mic, please mute yourself. This, yeah. So the gray code for 0 is nothing but 0 0 0 0, and then for 0 1 is this, and for 2 it's actually 0 0. You give me a moment. 1 1, and for 3 it's 0 0 1 0. I'll tell you how we can convert it later. But yeah, here the main difference that you see is, yeah, so the main difference here you see is the transition of from 0 to 1 is only 1 bit transition, right? What I'm trying to say is, maybe I can, yeah. So here this 0 is changing to 1. The transition is only a 1 bit transition, right? And if you see the transition from 1 to 2, it's this 0. Now the second 0, maybe I can take some other color. This green 0 is changing to 1. Rest of the bits are remaining same. Then if you see the next transition, which is this one is changing to 0, rest the bits are same. So the gray code basically it is a code which only has a single bit transition. I think this transition or this conversion will take up in some lectures later, but the whole idea of using the gray code, because it only involves a single bit transition, since and hence the error would be quite less as compared to the main the core binary conversion, because here you see, sorry, so here you see in from transition from 1 to 2 there is a 2 bit transition, right? This 0 1 has been changed to 1 0 here. So this is a 2 bit transition, and we do not want the digital bit to be transitioning like that, because that will introduce more error in the circuits or in the actual systems. So hence we use a gray code formation, and that is why I have written 0 1 here, and then 2, since the gray code of 2 is equivalent to 1, so I have written 2 here and 3 first because the
Okay,
equivalence
ma'am.
is 2. Who is it? Someone has opened their mic. Okay. How to convert gray to binary? Okay, yeah, fine. If you want to know right now only, let me tell you. So let's say you have a binary number, for example, 0 0 1 1. Let's say, for example, let's say 2. Let's say this is a binary number and you want to convert it to a gray code. So it will come later in the course outline also, but yeah, let's see that. So to convert from binary to gray, what you need to do is you need to keep the first number same, that is 0, right? And then you have to do the continuous XOR of the first and the consecutive digit. So 0 XOR 0. XOR means, I think you already know, A XOR B is nothing but A B complement plus A complement B. So this will be covered in the next lecture, which is the logic gates. So 0 XOR 0 gives you 0, then 0 XOR 1 give you 1, and then 1 XOR 0 will give you 1. So this is the binary 2, which is equivalent to 3 in gray. So this is how we do the binary to gray conversion. Is it fine for now? I mean, this is just a basic conversion, how we do it. It will be discussed in details in the next classes, so don't worry about it too much. So yeah, let's come to the problem now. I think we have covered enough. So now here the question
Sir,
says, yes,
sir, in lectures are taken, you taken no, sir, 0, 1, 3, 2 from left to right now, sir.
left to
In
right.
in,
Yes,
in the K map, sir, 0, 1, and
yes,
then 3, 2 in from left to right now, sir.
yes, yes.
In lectures, sir has taken like from top to bottom, sir. 0, 1, from bottom to 2, 3. Is
Oh,
it
okay, okay.
equivalent, sir?
Yeah, okay, okay. I get, I think what you are saying. So maybe you are trying to say that it has been taken 0, 1, 2, 3.
Yes, sir. Yes, sir.
Okay, yeah. So it can be taken like that if the first two bits, for example, let's say P, Q are here and R and S are here, then it is equivalent because the 0, 0 is constant here and then the next bits. So we can do it like that also, but in that we have to change the PQ here and RS here. Is it fine?
Yes, sir.
Okay. So now the first term in this particular problem is PQS. So I hope you already know how to fill a K map, but how we can fill is, so first we need to see what is the common space or the box that we are getting from the term PQS. So here you see the PQS is involved in this. This basically, this complete row is PQS, right? Then the third term is S. Now the S is here and here. So if I try to make boxes, so this will be S, right? So now the common or the intersecting terms wherever are there, we need to just fill them with 1. So the PQS is nothing but 1, 1, 1, 1. Is it clear to everyone? I mean, this is a basic thing that you should be knowing to solve any problem. If you have any doubts, quickly ask me. Otherwise, we can move ahead. Okay, fine. So the second term is P bar. P bar is basically these two lines. Then there is R bar as well, which are the first, which is the first column basically. So let me write that. So this is P bar R bar, the first column. So basically the intersection points are 1 and 1. Similarly, it's P bar Q. So P bar Q is this line. Problem is, so now the third term is P bar Q, which is the second row. So I've filled it with 1. The third term is P bar R S bar. So P bar we have already covered. Then R S bar. Who is it opening their mic again and again? Please mute yourself. It is creating a lot of distraction. Yeah. So P bar R S bar. So P bar is these two, and then R S bar is this. So here it would be 1, 1. Then the last term is PQ bar, which is PQ bar is the last row, which is this, and the S bar. S bar is here and here. So these are all the ones that we need to use or to minimize the expression, right? I hope this is clear to everyone. So now in the K map, the second step. So first is marking all the ones. The second step is to make
Sir, can you explain again, sir?
which part? The filling of K map?
Yes, sir. The filling, it is new to me, sir.
Okay, okay. Yeah, let me do that again. Okay. So let me make a new box. So let's say this is P bar, Q bar, P bar, Q, PQ, PQ bar. So I'm not writing 0, 1, 2. So I'm giving you example of, let's say, two terms. So the first term it says PQS, PQS, right? So we need to mark the common area, right? So where do you think PQ is? PQ is this row, right? That is this row. You understand this?
Sir.
Yeah, and the term from the top is S. So S is present where? S is here and here, right? Basically this particular box. Right, you understand this?
Sir.
So the common region that you see in the intersection will be marked as 1.
Oh, okay, sir. The common region of PQ and yes, we should mark one, sir.
Yes, yes.
Ah, yes, I understood. Sir. Thank you,
Okay.
sir.
Yeah, great. So quickly, if I can tell maybe which is very easier. So there is one term which is P bar Q. P bar Q. So where do you see P bar Q? Here, right? So if you see P bar Q here, which is this row, right? Now since there is no other term, so all of these should be marked as 1. You understand now?
Yes, sir.
Okay, yeah. So similarly, I have filled it like these are all the ones that are required. So basically that was step 1, that is marking the ones in the K map. The second step is nothing but, okay, let me write that so that, okay, where are all the ones? I can rewrite those. One are all the corners.
Sir, in that case,
Wait,
there
wait,
is
wait,
no common
wait.
reason.
Don't shout again and again. I think I warned you in the next class also. Please try to speak in a lower tone. What are you trying to say? Say it again.
Sir, is there any cases there is no common reason are present?
No, it is not possible because we are taking the common region, right? It is not that we have marked those. The question, whatever is saying, we are making the regions accordingly. It is not possible that there is no common region.
Okay, sir.
Common region, there is no common region means the term is basically 0. That is not possible because there is some expression. So yeah, these are all the final ones that we have come up with. Now we need to, as I said, the step 2 is we need to make largest possible pair. That that is in order of 2 raised power n. That is either 2, 4, 8, 16, whatever the largest pair that we have. Oh, not pair, but we can say largest possible groups. So a group of 2 is called as pair. A group of 4 is called as quad. A group of 3 is known as octet, and so on. So here, if you see, if I try to make that, maybe with some other color, yeah. So one possible, so first of all, we cannot make a pair of 8, right? Because we do not have any consecutive ones that are present in a pair of 8. So the one quad that I can see or I can make is this, right? Then one more that I can make, maybe I can use some other pen which is visible. The other one that I can make is this. Okay. Okay. Sorry for that. Yeah. What I was saying is, so the one is this thing which has these 4 ones. One is this thing which have these 4 ones, and all the corners are again 1, 1, 1, 1. Are you able to understand this? These are the only quads that we can make in this particular problem, right? Please let me know if this is clear, then I can quickly write the expression. Okay. So this particular thing we can write because it is completely one row, so we can write it as P bar Q, right? This particular box is what is common in this. So one thing common is Q, and in this one common thing is S. So we'll write this as QS. The third corner one, the common thing is one is q bar, and here it is r bar, or not r bar but s bar. So what was that? R bar, and it was q bar. Oh, I'm sorry. It was s bar, I think. It was q bar, s bar. Yeah, so largest consecutive is possible at 16, but that will give you one only, because if you write one in all the boxes, that will be basically that 16 pair, and that is basically equals to one only because there is all the ones. So let's see the option. So we have got three terms: p bar, q, 0 to 4 6 are also in quads. Okay, so let's do that. 0 1 2 3 4 5 6 7. So 0 to 4 6, yeah, so we can make a quad like that also, that is true. Okay, first of all, let's just check the option. This option should also be correct: p bar, q, qs, and q bar, s bar. So p bar, q, qs, and q bar, s bar. So one option is this. So maybe the second option that we can form is maybe this one. So q bar, s bar is common, and then qs, p bar, s bar. Okay, qs and q bar, s bar. So p bar, q is that thing. P bar, q, oh, p bar, q, qs, p bar, s bar. Hmm. Yeah. So we can form this also as a quad that is suggested by someone. That is also true. And then this and this. So the this term will get replaced by p bar, and then this is s bar, which is basically this option. So both this and this. Okay, so there is an option like that. Yeah. So the last option is correct. Is it clear to everyone? Okay, yeah, great. So I
Sir,
think yes.
then we have to do multiple variants of it to find this, sir.
Yeah, it is
Like,
possible to have a multiple variant, but those multiple variants should also have the minimum terms. For example, it is not possible ki you are having more terms in that second variable. So that is not correct. You are trying to minimize it, and there are two possible solutions that are equally minimized. So that is why we have done that, because in this it is clear that we can make a quad like this also, instead of just making a quad like a single line. I mean, instead of taking this p bar q directly, we can also could have made like this and this as one quad.
sir, then if the options are given multiple, then we have to check two variants, sir.
Yeah, if the both the options have same number of literals, then yes, you have to check both the options. But in general, they only give a single option, so I think you should not worry about it too much.
Yes, thank you.
Yeah. Okay. So yeah, I think we can move now. So this is the next problem. It says if a, b, c are Boolean variables in expression this, find the complement of f. Okay. So f is given, you need to find the f complement of f, basically f bar. So let's do that. So yeah, first of all, there can be two ways, as I said, to minimize. One can be Boolean identities. That is what we have somehow covered in the last lecture also, and one is k-map. So you can use any method to minimize this. So let me use the Boolean identities for this, because
Sir, one doubt, sir, last time.
yes.
Sir, in the above options, there was a P bar Q plus. Can you show the answers?
Yeah.
There QS plus Q bar S bar is there. No? So
Yeah.
can it be simplified to one, sir? P bar Q plus one. So one.
What
So
is
the
simplified to one? These two terms.
yes, sir,
This.
plus one, no, sir. So the term plus one equals to one, no, sir.
No,
So
no, no.
second option will be
I mean, you are saying q bar qs and q bar s bar equals to 1, right? You are saying
no.
this?
Yes, sir. Yes, sir.
No, no. So this is not equals to 1. So okay. So actually qs plus qs whole bar is equals to 1, and this is nothing but q bar plus s bar. So don't get confused. So basically a plus a bar is equals to 1. Here your a is, if your a is let's say qs, then the qs should be complemented, completely complemented. And this is actually q bar plus s bar. Hence this is nothing, this is not 1. These are two different expressions because we have q bar and then s bar. It is not like qs whole complement. You understand this?
Yes, sir. Thank you, sir.
Yeah. Yeah, so we were here. Yeah, so we need to minimize this function, which is a bar plus b plus c, then b plus c bar, and then a plus b plus c. So let's do it like in a very conventional way. So let's multiply these two. So it is a bar b plus a bar c bar plus b plus b c bar plus b c plus 0. And we have this a plus b plus c as it is. So I can take, I think, b common from these three, and that will give me 1 only. So I can write this as a bar b plus a bar c. Okay, let me write that. So it will be 1 plus c bar plus c plus something something, and then a plus b plus c, right? So this will be nothing but b. A bar c bar is there. Oh, sorry. So a bar b and a bar. So this is c bar. I've written it wrong. B plus b c. Huh. Yeah, no, it is correct. So I can also take common b from here also. So let me rewrite this. So it is a bar c bar plus, I can take b common from this also. It is 1 plus a bar plus, yeah, not multiplied, but so this whole term is nothing but b. So it is a bar c bar plus b multiplied by a b c. So now if you know that any complement multiplied by that common term is always 0, so I'll not write. So a multiplied, this is 0. So the first term that I can get is a bar b c bar. Third term will again be 0. Then from b I can write a b plus b plus bc. Do you understand? So again, what I can do is, I think I can take b as common from all the terms. So it will be a bar c bar plus a plus 1 plus c. So 1 plus any expression is always equals to 1. I hope you know that. So this will be nothing but b times 1, and this is nothing but b. So this is what we are solving for f, right? Is there any doubt in this? Please let me know if there is any doubt. Okay. So if there is not, what we need to find is something. Which case of p bar q bar? No, it is not equals to 0. Okay. So, oops.
Sir, one second, tell me, sir.
Which problem? This one?
Yes, sir. Final answer. One
Okay.
second, tell me, sir.
Sure, sure. So for the previous query, that this pq plus p bar r bar, oh sorry, p bar q bar, just give me 1 minute. So this is not equals to 0. This is like p x nor q. I mean, this is some expression. So pq plus pq whole complement could have been equals to 1, or pq times pq whole complement could be equals to 0. But the question here is p complement and then multiplied by q complement. This is nothing but p complement plus q complement. So don't, where, how will it be 0? Which term are you asking about 0? Rama, could you please clarify? C plus C bar is 1 and it will be.
B into A bar plus 1 plus C bar plus C, sir.
Yeah, so this term I have written as b, not 0. So yeah, 1 plus anything is 1, right? So b multiplied by 1 is b. So this is I have written as b and not written it as 0. Is it clear now? Okay, let me maybe go through once more. So in these terms, I can take B common from this, right? So taking B common, so here I will having A bar, then from here I'll be having plus 1, from here I'll be having C bar, and from here I'll be having C. And the only term left is A bar, C bar. Who is it?
Yes, sir.
Yeah. So if it is like this, so this 1 plus any term will be 1, like it will be B multiplied by 1, and that is equals to B only. So A bar, C bar plus B I have written as this term, and this ABC I have kept here. I hope it is clear now. And someone else also asked to do it again. So now multiplying A complement with A will always give you 0. So I have not written the first term. So now multiplying A complement C complement with B will give you this. Then multiplying C complement with C will always give you 0. So that is why I have not written that term. So only one term is left by multiplying this with all these three. Now by multiplying B with all these terms, so the first term will be AB, which is this. The second term will be B times B, which is B only. The third term will be B times C. Is it clear till here? Whosoever has asked, is it clear? Okay.
Yes, sir.
Yeah. So now what you can see is I can take B common from all these terms. So if I take that, so it will again become A complement C complement from here, then A from here, then 1 from here, and then C from here. So 1 plus any term will again give me 1, that is B times 1, and it is nothing but B. Now the question has asked about complement of F. So this is actually F, so the complement of F will be B complement, right? So the answer would be option D. I hope it is clear. Let's move to the next problem. So it says a simplified means you need to do a minimization. Expression for the given expression will be what? So okay, so one thing that you notice, it is just W, X and Y. So this is three variables. Hence this is 8-bit K-map, right? So you can quickly make a K-map and see what is the minimized form. Maybe you can take 2 minutes and let me know what is the answer.
మీ ఫోన్ చేస్తున్నా
Sorry, I did not get it. What did you say?
Yeah.
Okay, there is one more doubt. Yeah, so you can check. So again, for the previous problem, you can make like it in a SOP form and make the KMap, or you can also make it in the POS form, that is product of sum, like it is given, and then you can make a KMap for that. I'll do a similar problem using KMap also, don't worry about it, because this was easier to do it in a conventional way. I've done it like that. So like this is like a similar 3-variable problem, so we'll do this particular problem using KMap. Okay, so any answer, guys? Anyone? So I got one answer as both A and C. So let's check that. So here the three variables are W, X and Y. So I'll write W bar W, X bar Y bar, X bar Y, X Y, X Y bar. Again it's 0, 1, 2, 3, 4, 5, 6, 7. So let's mark those once again. So the first term is W complement, X complement, Y complement. So W complement is this row and X complement, Y complement is this. So the common term is this. Then we have Y times, so Y is present in these, sorry, y is present in these two, and then wx, okay, I need to, I think, write it in a simplified way. Let me do that also. W complement x complement y complement is the first term. The second term here, it's y wx bar whole complement. The third term is w complement y plus wx. Okay, so the first term remains the same. The second term will be y, then this will be w complement plus x using the De Morgan's law. Then we have w complement y, and then w complement w will be 0, so I'm not writing that term. So this will be w bar x bar y bar, this will be w bar y plus wx. This term is this w bar y. Oh, so this is repeated actually, so we can also ignore this. So this is the final thing. So w bar y is the second term, which is again this is w bar and y is in these two. So here there will be two ones. The last term is w and then x. So w is this and x is basically these two. So here, did I write something wrong? Sorry. So this will be xy, w bar y and xy. Yeah. So x and y is this basically. Sorry for that. Mhm. So this is xy bar. So this is xy, and hence the one will come here. Is it clear how I filled this K map? Please let me know if it is clear quickly. Okay, I hope it is clear. So we can, what we can do is we can only make pairs, right? So one pair we can make this, the second pair is this.
Uh,
So the answer would be one is this, which is w complement and then x complement. So the first thing is giving me w complement x complement, and this is giving me xy, which is option. Is there any option like that? Yeah. So option C is the correct answer. So here you see it says both A and C also, but what w complement is complement, but x complement y complement is not there. So for that here it should also be 1. So it is not correct. So option C is the correct answer, right? Why the last term neglect? Which term did I neglect? What about option D? Okay, so let's see what is option D. Option D is x complement y complement. So x complement y complement cannot be the answer, right? There is no one here. To have x complement y complement, we should have a 1 here. There is no one here. Is it clear? There are 3 pairs. Where are the 3 pairs? Can you elaborate? What are you asking? Whosoever it is. Uh, y bar w. Okay, y bar. Sorry, w bar y. W bar and then y. Oh, I get it. You are trying to say this. So okay. So since we have already covered these two ones as in of other pairs, so we should not write this. So I mean, yeah, what I'm trying to say here is, so if we write, let's say xy plus w bar x bar, so this is the answer that we have written. And if we write x bar plus w bar x bar plus this term is w bar y. So this is basically equivalent to this. So the minimized form of this is basically this. So hence this is the answer. We need to find the minimum expression. So that is why 1 3 is neglected. Is it clear? Yeah. So let's do this now. So it says for the Boolean function, please don't open your mic again. Mm. So it says for the Boolean function ABCD, which is this, what will be the correct form of sum of products? Okay, it sum of product means summation only, like the min terms. So yeah, this is very easy. If you just make a K-map and all marks all the one, that will be the min terms. Do you want to do that? Just give me, yeah, just try it out and let me know the answers in the chat box quickly. Okay, so I've got one answer is 02689. So yeah, let me do that. So ABCD, that means A bar, B bar, A bar, B, A, B, and then A, B bar, C bar, D bar, C bar, D, C, D, and then C, D bar. So it says the first term is AB. AB is this, right? So these four will be one. The third term, oh sorry, the second term is A bar, B bar, and then C is common in these two. So these two will be one. Are you getting how I filled this K-map? Any doubt? Please let me know quickly. Okay, so we need to find the min terms. So whatever the ones are the min terms. 6, 7, then sorry, 8, 9, 10, 11, 12, 13, 14, 15. So basically the min terms are 2, 3, and then 12, 13, 14, 15. Is there any option like that? 2, 3, 12, 13, 14. Yeah. So option 1, 2, 3, 4, 5. So option E is the correct answer.
And sir,
Is it clear? Yes, yes.
sir, unlike last time where we did for sum of products C plus C bar like that, we are avoiding it using K-map to find it, sir, directly.
Say it again. Last time,
No,
like this.
not this time, sir. For in the last week time when we want to find sum of products,
Hmm.
we did the expansion by assuming C plus C bar.
Oh, so last week we have not covered KMAP. I think this is what you're saying, right?
Uh, not sir,
Yeah,
not
yeah.
like
So
that.
why? Because the this KMAP was a topic of the next week. So that is why we did everything by expanding like in a conventional way. So in this lecture we are doing all the KMAP problems. You can
No,
do
sir.
the last week problem also using the KMAP. That would be easier. That is true.
Yes, sir, yes, sir. Unlike using conventional process, if we do like this means we can easily get, sir.
Yes, yes, true. So yeah. So the answer would be option E. Is it clear? I hope it is. So let's move ahead. So the next problem is the minimum. So minimum means you have to minimize the expression, the number of literals present in the SOP form for this. So can anyone tell first of all how many literals are there in this expression? Anyone having any idea?
3, sir.
3, sir. Answer is 3.
Answer is 3. Okay, answer is 3. Let's wait for the answer. Can anyone tell
Why? Because
how many literals are there in this expression without any what to say
as we are
simplification?
having only 3 options,
Okay.
A, B, C, sir.
Okay, so okay, let me give you a clarity. So A, B, C are the variables, and literals are any repetition of the variable. So there are three variables, not literals. So literal is something different. So here the literals are A, B is 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 literals in these expressions. Is it clear to everyone what I have done just now?
Sir, C bar and C bar again, we can take as separate
Yes,
separate
yes,
literal,
yes,
sir.
yes. Yeah, I agree with that, but I'm telling you this expression has 8 literals. So we'll do the minimization, and yeah, the final answer is not 8, but yeah, we'll do that minimization later, but I'm trying to tell you what is literals. So
So, sir, what is literal in the sense? Every term,
yes,
every
yeah, every
term,
term in the
term is
expression is counted as a literal. Whether
okay,
it
sir.
is A or whether it is A complement, it is a literal.
Okay.
Sir, then 6, no, sir.
Yeah, yeah. So let me do the simplification now. So it's A bar B C bar, sorry, whole bar, then A bar B C bar. Okay, so let's do using maybe K map quickly.
Sir, once again tell me what is equal. Your voice is not clear, so that's only I asking you, sir.
Okay, is my voice clear, everyone?
Yes, sir. Yes.
Yeah, yeah. Okay, so let me tell again. So any term or any uh, every term in this particular expression is counted as a literal. So for example, I said that this A is one literal, this B is second, this A bar is 3, this B bar is 4, this C bar is 6, oh sorry 5, then 6, 7, 8. So there are 8 literals in this expression. This is what I just told you. But the minimum number of literals is not 8 because we can minimize this expression and then we can find the number of literals.
Sir, one doubt, sir. You
Yeah.
said that literal is a repetition. That means A is repeated, A bar is repeated 2 times, no? So we have to count A bar as 1 literal or
No,
2
no, no.
literals.
So by repetition, I meant that even if A and A bar are repeated, so it should be counted again. So yeah, this is actually quite,
Okay, sir.
yeah, you can say every variable or every term in an expression is literal. Is it clear now, everyone?
Yes, sir.
Okay, so B bar C, let me do that quickly. So we need to minimize this to find the final answer. So first is A, B. So A is here and B is here. So these two will be 1. The third term is A bar, B bar, C bar. That is this. The last term is A bar, B, C bar, A bar, B, C bar, which is this. So hence how what we can do is we can make, oops, sorry. We can make this as one pair and maybe with some other color, this as one pair. So the answer would be is A, what is common B, and the red block has A complement, C complement. So is it clear? So the number would be 1, 2, 3, and 4. Yeah, so 4 is the correct answer here, which is option this. Okay, yeah, final answer is 4. Yeah, that's 4.
Sir,
Yes.
sir, without using K map, can we say like A one literal, A bar another literal, here B one literal, B bar one literal, C. So 5 combinations like
No,
that
no,
we
no, no,
can
no.
say.
So without simplification, you are saying? So without
Yes.
simplification, it has 8 literals, as I told you. And by using simplification, it has 4. So final answer is 4 because it is asking for a minimum. Is this your doubt, right?
Sir.
Okay. So let's move ahead now. So it says what will be the correct product of sum. So it is asking for product of sum for the Boolean expression. Oh, mentioned in question 5. Sorry, sorry. So the previous question is related. So, okay, first of all, can anyone tell me what is the final function of this? Let's say this is f. What will be the midterms? Quickly.
Zero, 2, 6, 7, sir.
Okay, so 0, 1, 2, sorry, 3, 4, 5, 6, 7. Yeah, so 0 to 6, 7. So the previous problem has the final answer of midterms as 0 to 6, 7. So I've just asked just to make your problem easier. So now it says what will be the correct form of product of sum for the Boolean expression mentioned in question 5. So can you tell now quickly, everyone?
This, sir.
What?
1345, sir.
Yeah,
Option C.
yeah. So basically the max terms are nothing but the complement. So it's 1, 3, 5 is not there. 1, 2, 3, 1, 0.
Sir, once again repeat, sir.
So 4 is also not there and 5 is also not. What do you want me to repeat? Which part?
Sixth question, sir.
Okay,
Sixth
okay, six.
question.
Okay. So it says we need to find the product of sum for the problem in question 5, and the question 5 has this answer, which is the min terms are 0, 2, 6, 7. So we just need to find the max terms that are basically the product of sum. So whatever terms are not present in this will be the max terms, right? I mean, this is what we already did in the last lecture also. So there is no 1, there is no 3, there is no 4, there is no 5 in this. So hence the answer would be 1, 2, 1, 3, 4, 5, which is option C.
Okay, sir. Okay, sir.
Yeah. So let's move ahead. Okay. So now it is asking the following K-map represents a boolean of four variables. Which of the following given option represent the minimum form? Okay. So I just tried to do that. So let me give you the easier way. So let's say this is A bar B bar. The way it is written is kind of confusing. This is A B. This is A B bar. This is C bar D bar. This is C bar D. C D, and this is C D bar. And basically this line is the 4 cross 4. So yeah, you need to find the final expression. Maybe you can take 2-3 minutes because this is very easy, I guess. And let me know the answers in the chat box. Okay, so I've got option C as some of the answers. So let me try that by myself. So the first, I mean, the clear quad that we can see is this. The second, maybe I can make with some different color. So these two ones can be converted with the quad by these two. So the second quad is this, and these two ones are remaining now, which is like kind of a pair. So these are the three options that we can have. So this is basically the first term is A bar B bar. The second term, which is in green, let me mark like this. The green term is B bar is the common term from top, and D is the common term from this. The yellow one is A C D bar. So the final answer would be A complement B complement plus B complement D plus A C D complement. Is there any option like that? A complement B complement B complement, P complement plus B complement D plus AC. Yeah, option A is the correct answer. Let me see what have you written. Yeah, some are saying option C. So please recheck your calculations and let me know if it is clear now. Yeah, good. Shall we move ahead?
Okay, sir.
Okay, great. So this is some again.
Sir,
Yes, yes.
sir, in before question, A bar B bar plus A B bar D plus A C D bar, yes, sir.
A bar, B bar. Is there any option like that you are saying, or let me just write what you are saying? Maybe you are saying A bar,
C
B
bar,
bar,
yes, sir.
and
A plus A B bar D
A, B bar, D
plus A C D bar.
plus A, C, D bar. Oh, okay, okay, I understand. So you are okay. So basically, you can not make these two as pairs because then it will be repetitive, right? You need to find the simplest or the minimized form. So actually, these two, if you make like pairs, so this you don't want to because this now this thing has an extra variable, right? You see here, and this is just b by d. So this is the minimized form actually. This is not. So that is why this is not the answer, and this is I have only written as b by d. Is it clear? So instead of making this as pair, I have made it a quad like this, so that I can minimize one more expression or one more variable.
Okay, sir.
Yeah. So yeah, everyone please try this. Okay, so this question has a X, that means don't care. I hope you already know that. What is don't care? Let me know the answer maybe in the chat box and then I'll also try to solve it.
Sir,
Uh,
previous, can you explain, sir, that BD how came?
what are you saying?
Yes, sir.
In this
This
question,
B bar D, sir. Yes, sir. B bar D, sir.
oh, oh, so B bar D is this. Okay, so this I can make quad with this, right? This is B bar D.
Sir, then overlapping allowed, sir, from above
Yeah,
horizontal one.
yeah, yeah. So overlapping is
Oh,
allowed.
okay.
Yes, yes. So this is one quad. The second quad is the green one. The third pair is the yellow.
Sir, here A, B bar both didn't change, no, sir. So we should take both, no, sir.
A, B bar, which,
In the bottom row, A,
uh,
B bar is constant for both the ones, no, sir.
no, no. So A, B, oh, sorry. What is this? So this has A, B bar common and this row has A bar, B bar. So hence only B bar is common for these four, right? You do you understand this?
Okay, so then we have to compare top one and bottom B
Yeah, yeah,
bar,
yeah.
sir.
Yeah. So for example, the first complete row is A bar, B bar. That you understand, right? The red one.
Yes, sir.
Similarly, so for example, I can give you a very basic example here. We have some K map. So for example, let's take this. So this particular row has A in common, right? The blue one that I marked.
Yes, sir.
And since the two ones are here, so these two particular column, what do they have in common? They have common B, right?
Yes, sir.
So I have written it as AB. That is why I have written like that. Is it clear now?
Yes, sir.
Okay, yeah, great. So anyone with this? Any answer? Okay, so let me do that. So don't care is like you can take, so let me explain. So don't care, you can take 0 if you don't need it, and if you need x, you can take it as 1. So by need x, what I am meaning to say is, if you want to make a pair or quad, and if there is any one that is lying, so you can take that one as maybe x and make it as a pair or quad. Otherwise, you just need to keep it as 0. So for example, in this problem, the one pair that I can make is maybe this and this, right? Then the second pair that I can make it this, and the third one is left like that. So what can I do? I can make a pair with this. Is it clear to everyone how I made the 3 pairs? If not, please let me know.
Once again repeat, sir.
Okay. So what I have made is, I can make these two corners as one pair, these two as one pair, and since this one is left like that, so I can make pair this as this x. This x can only be made as 1 if you need it. Otherwise, all the x will be counted as 0. Now what I'm trying to say, even if you make this as 1, this is not helping, right? This is not making any quad or something. If this would have been x, I would have made this 1, and this, but whole thing would have been a quad. Is it clear now?
Okay, sir. Yes, sir.
Yeah, so the answer would be, so the red one again.
Sir, answer B is the correct answer.
Okay, yeah, so let me see. The red one is B bar is
Um,
common,
B.
C bar D bar is the first, then the green one is B, C bar D, and the yellow one is D bar C D. So let's see what is the option. So it says B bar, C bar, D bar, B, C bar,
B.
D. Yeah, so option B is the correct answer.
Yes, sir.
I hope it is clear to everyone. Option B is the correct answer here. Yeah, so if it is clear, then let me know the answer to this quickly. I'll wait for 2-3 minutes. You can all type your answers in the chat box. So I think I've got the last first option. Okay, some are saying B, some are saying D, some are saying A. Yeah, let's see that. So as I told you, what we can do is, we can use X as 1 if it is helping us in making any pair. So, or a quad even. So these two ones, as I can see, I can make these as 1. Then I can even make a octet here. How I can make an octet? If I can use these all x as 1. This is one octet, and even I can make octet for these one also. So this would be my final answer. All the three are clear to everyone before going towards the expression? Any doubts
Sir,
here?
once again, repeat, sir.
Okay. So what I'm trying to say, I can only make x as 1 if it is helping me. So these two ones were lying like that. So if I just make these two x as 1, this would give me the first quad. Then this is 1, this is 1. Oh, sorry. I mean, this is 1, this is 1, this is 1. If I make this x as 1 and all these x's as 1, these four, like this particular column, then this green one would be a first octet, right? And these also are ones, maybe the red ones, that is this particular column. If I make all the x's as 1, this would be my second octet. I just want to minimize the expression. So whatever higher possible group, quad or octet I can make, I will make that. Is it clear now?
Yes, sir.
Okay. So let's find the expression now. So the answer would be, so one is AB. I can clearly see the yellow one is AB. This particular row is AB. Then the octet is the red one. For the red one, the common part is D only. And for the green one, the common part is C. So the answer would be AB plus C plus D, which is option A. So if you make any when, yeah, if you have make it 1, it is always 1. Wherever you want the x to be 1, it will remain 1 there. Any x can be 1 or any x can be 0 as per your convenience. That is why we called it as don't care. Is it clear? Yeah, great. Let's move ahead now.
Sir,
Yes.
should we want to take don't care terms also, sir?
Should we what?
Should we want to take don't care terms also, sir?
Yes, yes. So using those don't care only you have minimized, right? So you have to count those don't care as 1.
Without using don't care terms also we can do, no, sir?
That will give you a bigger expression. You need to find the minimum, right? You need to minimize the expression. Without
Okay.
using the don't care, you will get a more bigger expression. For example, if you don't take, let's say, the CD, so you will be getting two quads, right? These two
Yes,
columns
sir.
basically. So that would be AB plus C bar D plus CD bar, which is very much higher than this.
Okay, sir.
You understand?
Yes, sir.
Okay, yeah. So maybe now all of you can try this problem. Do you have idea about the gates or and the basic idea? Okay. So I think if you not even have it, let me do that quickly. So for a OR gate, what happens is we have uh, OR gate is nothing but the summation. So this is OR. So any input is, if any input is 1, the final output would be 1. Then for AND gate, it is basically a multiplication, which is AB. So if any input is 0, it will be 0 because the multiplication is like that. So this is the basically the final input and output of the OR gates. So it says, I mean, the question is nothing but, so there can be two ways, either do the complete expression and all, but you can do it in a shortcut. So it says F1 or F2, that means F1 plus F2 basically, multiplied by F3 plus F4. Everyone understand this? Any doubts in this?
Once again, repeat, sir.
So basically this OR gate is doing the addition of F1 plus F2, right? This OR gate is doing the addition of F3 and F4. And these two terms are getting multiplied by this AND. That is F1 plus F2 multiplied by F3 plus F4.
Sir,
Is it clear? Yeah. So F1
sir,
is nothing but, oh yeah, yeah. You're not audible. Can you repeat?
sir, so can we do logic gate to functions also, sir?
Yeah, I'm just, so in functions, the plus operation is basically equivalent to union. The multiplication operation is basically equivalent to intersection. This you might have heard in your mathematics lectures in, I mean, classes in your school. So that is what I'll be implementing, or I'll be showing you how we can do that. I'm just like trying to write it in a simpler form so that you can understand. So F1, it is given, it is min term, which is 1, 2, 3, 7, 8. And F2 is min term 1, 6, 7, 8, 9, 15. Let me add a page. So F1 plus F2 is nothing, will be, it will be F1 union F2. That means the both the terms. Is it? So the final F, let's say FA would be the min terms 1, 2, 3, then there is 6, 7, 8, 9, 15. All the terms that are there in both of them will be the final answer. Is it clear? If there is any doubt, please let me know. Is this line clear to everyone?
Okay, sir.
Yeah. So similarly,
Sir,
F, yes.
common term should take only one time, sir.
Yeah, yeah. What's the point of repeating? I mean, there is only one in the term. Similarly, let's say FB is F3 plus F4, that would be, so F3 and F4. Okay, sorry, I think I have not written it correctly. So actually the F2 is this. I've written it wrong, my bad. The question says F2 is 1, 6, 8, 15. So it would be 1, 2, 3, 6, 7, 8, 15. Is it clear? I've written the question wrong, sorry. Is it clear for F1, F2? Similarly for F3, F4, we can do, so it's 1, you can see it here, huh? F3, F4 are written here. So 1, 3, 5, 6, 7, then 8, 9, then 12, 13, 15. Is it clear to everyone? F3, F4 also? Please let me know if you have any doubts. Any doubts, anyone? Okay. So now basically the final answer would be FA times or FA multiplied by FB. That means you have to take the intersection. Only the terms which are same in both the FA and FB will be the final answer. So it is main term. So let me do that. Maybe let me. So 1 is common, right? Then 3 is common, then 6 is common, 7 is common, 8 is common, and then 15 is common. So the final answer would be 1, 3, 6, 7, 8, 15. Is there any option like that? 1, 3, 6, 7, 8, 15. Yeah, 1, 3. Option D is the correct answer.
Sir, can you once repeat this one, sir, please?
Which one?
This,
This
please
last step?
once. No, no, before previous, sir.
Okay,
Just
okay.
I
Like both.
understood this
Okay,
one.
okay. The complete question you're asking, right?
Yeah, yeah,
Yeah, yeah, no problem. So, for example, what I have done is the question says F1 or F2, F3 or F4, and it is multiplied by F. I mean, both are getting end. So, this is the expression that we were calculating. So, in the question, F1 is given as the min term 1, 2, 3, 7, 8. F2 is given as the min term 1, 6, 8, 15. So if you are doing any OR, we need to take all the terms that are associated in both. That means 1, 2, 3, then 6. We also need to take 7, 8, and then 15. So that is what I have written here for the F1 plus F2. Is it clear till here?
Okay, sir. Yes, sir.
Yeah. So similarly, F3 and F4 you can check from here. So it's 1, 3, 5, 6, 7, 8, 9, 12, 13, 15. So that is what I have written here for F3 and F4. And now when you are
Yes, sir.
multiplying it by and, you only need to take the terms which are common in both. So that I have highlighted by yellow color, which are 1, 3, 6, 7, 8, and 15. So that is the final answer. Is it clear?
Yes, sir. Suppose if I repeat this, suppose the final expression is repeated 4 times, F, then in when there is an AND operation, only the common term should be taken, sir.
Yeah. What do you mean by repeated? Which expression?
Suppose after minimizing, I have got the expression F value.
Uh,
Suppose in K map also, they
uh,
have given a function and I have got a value. I have got a function, reduced function F,
hmm.
and they have asked to find out the minimum, reduced minimum of F, 4Fs they have asked, sir.
Yes, yes. So that would be the ones in the K map also.
Yeah, that's what.
Yes, yes.
For
And
that only I have asked again, sir. Yeah.
sorry, from what?
So for that purpose only I have asked you
Okay,
again once to repeat, sir.
okay,
So
okay.
the K map also the same concept.
Yes, yes, true. I mean, you in the K map you
Okay.
can try this as A, B, C, D, and just try to make the K map.
Yes, sir.
Yeah.
Thank you, sir.
Sir,
Yes.
sir, if there is doesn't given the values of that question, so how can we suppose any random values?
How is it possible if the question doesn't give value, how can we solve it? The question
No,
should give
sir.
some
I
values.
want to ask that we can choose randomly number in that question if it doesn't given that values like 1, 2, 3, 7, 8. That question in this question given. Suppose
So
it doesn't given that.
it should give something that is then only we can solve, right? If it is not given
Okay.
anything, the question is incomplete.
Okay, sir.
Yeah. So now everyone, please try out this problem. So it
Sir,
says, oh yeah, sorry.
sir, just before you have discussed with Upendra, sir, no, sir, another member, sir. I can you explain it? I mean, what is that A, B, C, K? How is it related to K map, sir?
This problem related to K map, you are saying? Hello, am I audible?
Yes, sir, you are audible, sir.
Okay. So what were you saying?
Not me, sir. It's not me.
Oh, okay, okay. Someone was saying something, I thought. Okay. So maybe if their connection is fine, they can tell later. So now, yeah, let's try this problem. It says consider a circuit with three inputs X, Y, Z and three output A, B, C. When the binary inputs are 1, 3, 5 or 0, the binary output is 2 greater than, oh, okay, let me make that, okay. So it has three inputs X, Y, Z. So since it has three variables, so the options could be 4, right? I mean 8, sorry. So it is basically 0, 1, 2, 3, 4, 5, 6, 7. This is in the decimal notation. And the output is something called as ABC, it says. So it says the inputs, when the binary input is 1, 3, 5, and 0, that means 0, 1, 3, 5. Yeah. So the output is 2 greater than that the input. So 0 is actually giving out the output of 2, right? 1 is giving out 3 I'm just adding 2 in every option. So 3 is giving out 5, and then 5 is giving out 7. Is it clear to everyone?
Yes,
Okay.
sir. Yes, sir.
When the input is 4 or 6, it says the output is 3 less than that the input. So 4 is here, where, yeah. So 3 less means it is 0, 0, 1. Then 6, it's here. 6 minus 3, it's 1. Oh, 6 minus 3, it's 3. Then when the binary input is 7 and 2, which is left now, the binary output is same as the input. Oh, so 2 is 2 only, and 7 is 7 only. Is this table clear to everyone?
No, sir. Once again, repeat, sir.
Okay, so it says when the input is 1, 3, 5, or 0, that is these 4, the output is 2 less than that. So, sorry, what? 2 greater than that. So, 0 is marked as 2. So, 0 plus 2 is 2. So, that is why I have written it as 0, 1, 0. Similarly, 1 I have written as 3, 0, 1, 1. 3 I have written as 5, that is 1, 0, 1. And 5 I have written as 7, which is 1, 1, 1. Similarly, the plus minus thing happens to other numbers. So, 4 and 6 is giving 3 less than the output. So, 4 is giving actually 1 and 6 is actually giving 3. I mean 4 minus 3 is 1 and 6 minus 3 is 3. So 4 I have written it as 1, which is this line, and 6 I have written is 3, which is this line. And for 2 and 7, the input and output are same. Is it clear now? So it is asking for expression of A.
Yes, sir. Yes, sir.
Yeah, so for the expression of A, we only need to take the terms which are having 1, which is this, and this. So basically, A is nothing but, sorry, basically A is nothing but x complement yz, which is 3 here, plus 5, that is x y complement z, and the last one is where, oh, x y z. Is it clear to everyone? This is, I think, very easy.
Sir, once explain, sir.
So a is this row. Oh, sorry. So a is this row basically, or this column I can say, and it is one when these three cases, and it is one when this is this, and this is this. I can write this as x complement yz. I can write this as x y complement z. Wherever there is 0, I'm just adding a complement, and this is x y z. So I've done that, x bar yz plus x y bar z plus x y z. Is it clear?
Okay, sir. Okay, sir.
Yeah. So now we can do the minimization again. So it's x bar x, y bar z bar, y bar z, y z, y z bar. The first term is x bar yz, that would give me this as 1. The second term is x y bar z, that would give me this as 1. And the last term is x y z, that would give me this as 1. So the only two pair that I can form is this and this. The final answer for A would be x z plus y z, which is any option like that. Huh. Option A is the correct answer. Is it clear to everyone?
Sir,
Yes.
in case if they given for the input 7, take the output greater than 2 means then input,
So they,
then
yeah, they will
what
not
should
give,
we do?
right? Because it is not possible. They will never give you something
Okay,
that is
sir.
not possible.
Then like overflow
Yeah.
neglect like that we shouldn't do, sir.
No, no, no. So they will never ask you to go beyond 7. So that is why the question is framed like that.
Yes, sir. Thank you.
Yeah. So if it is clear, it is asking using the same data from question 15, we need to find the expression of B. So B is now, I think it's very easy now. So let's quickly do that. So this is one, this is one, 1, 2, 3, 4, 5, 6. These five things, six things will come. So maybe I can make a K map here for B. This is x bar x, again y bar z bar y z. So it's basically 0, 5, 2. Yeah. So what I can do is I cannot make any quad. So this could be one. So there could be multiple answers, I think, to this. These three pairs could be one answer. Let me rewrite this so that I can tell you what I'm trying to say. Okay, sorry for this. So what? Sorry, there's no one here. So one more thing that we could do is I can make this as one, this as one, and these two as one. Is it clear to everyone what I'm trying to say? So from the first block, the answer could be x bar y bar plus x z plus y z bar. From the second, the answer could be x bar z bar plus y bar z plus x, and this is y. So these two can be the possible answers for B. Is there any option like that? X bar y bar plus x z. Yeah, option A is the correct answer. Is it clear to everyone?
Yes, sir.
Yeah, so in your homework, you can also find for C. I'll upload this PDF after the class. Similarly, you can find for C. Yeah, actually, this is a question also. So you need to find the fee. So you can do this in your homework. This is actually very similar. So let me go to some other problem now. Yeah. So it says which of the following gates is equivalent to the given circuit? Okay.
And the gate
Sorry. Yeah. So this is a NOT gate. So this will be A complement. This is A, B. This is a NOR gate. So this will be A plus B whole complement. And this is nothing but A complement B complement. Similarly, this is B complement. This is B plus C whole complement, which is B complement times C complement. Here I will get A complement plus A complement B complement. Here I will get B complement plus. Is it clear to everyone? These things?
Yes, sir.
Yeah. So yeah, I can also minimize it here. So if I can do is A complement I can take common. It will be 1 plus A complement B. Sorry, not A complement. It will be 1 plus something. And this is basically A complement, right? And this is basically B complement. Is it clear? So the final answer would be A complement times B complement whole complement. Any doubts? And this is nothing but,
Option B, sir.
yeah. So Y would be a OR gate. Yeah, option B is the correct answer. Yeah. Similarly, you can do this in the following circuit. The output is. So here you see it would be A B whole complement, that is nothing but A complement plus B complement, and here it is C dot D whole complement, which is nothing but C complement plus D complement, and the inputs are again complemented. So basically F is nothing but A dot B whole complement plus C dot D whole complement. Is it clear to everyone? Have I done it correctly?
Yes, sir.
Wait,
One
wait.
small request, sir.
Yeah,
Can you discuss the problems on prime implicant and essential prime implicant, sir?
yeah, I have a problem. Let me do that. So basically, I think I've done something wrong here. So this should be AB actually, the input here. Here it would be CD. Oh, this AB plus CD, I think. Yeah, you can recheck. The answer is B. So yeah, I have last problem which is related to what are the essential prime implicants. So let me do that quickly and then we can wrap up the class. So please mute your mic, whosoever it is. Yeah. So it says which of the following is not an essential prime implicant. So let's make it quickly. Okay, so it says, let me write that quickly. Maybe yeah. 0, 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15. So it says 1, 4, 5, 10, 12. Where is 10? 10, 12, 13, 14, 15. So it says which of the following is not an essential prime implicant. So basically essential prime implicants are groups in K-map which have at least one unique one. I'll explain what does it mean. So basically let's try to make the groups first here. So the first quad that I can make is this, right? The second that I can make is this. The third that I can make is maybe this pair, and the fourth that I can make is what color I have not used. Blue I need to is this. Yeah. So here you see in we need to find the essential prime implements here. So this particular thing is it's if I write directly it's B C complement, the green one, the yellow one is AB basically. I mean this whole row. The red one it's A complement, C complement, D, and this is nothing but A C D complement. So now what you need to find is you need to find the not an essential prime implicant. So essential prime implicants are those groups in KMF which have at least unique one unique one. So here you see in this particular group there is this particular one that is not being shared with any other group, right? So this is one essential prime implicant. Is this clear to everyone? The green box. Please let me know
Yes,
if it
sir.
is clear.
Yes, sir.
Yeah.
Clear, sir.
Yeah. So similarly in this particular pair, this one is not shared by anyone. So this is also a EPI. Similarly, in this blue one, this one is not shared by anyone, so this is also a EPI. And in this particular AB, this one is also not shared by anyone, so this is also a EPI. So in this question, there are four essential prime implicants. So which are A bar, C bar, D. So this is cannot be the answer. So question is asking not an essential prime implicant. So AB cannot be the answer. Then A, C, D bar cannot be the answer. So the answer to this problem will be option C, which is B, C bar, D. That is no option also.
Sir, I am having small doubt, sir. This is clear, sir.
Yeah.
Uh, Sir, they have given a full adder, some result K map, and they have asked me to find out the expression. When I'm finding out the expression, simplified expression,
Hmm.
the result I'm going to get and what is given in the options are wrong, sir. Not matching, sir.
Okay, so you can share that problem with me over email. I'll check if you are doing something wrong. I'll let you know.
Okay, sir. Thank you.
Yeah.
Thank you, sir. And regarding here, how we can find out prime implicants, sir?
Yeah, actually, maybe I can tell you about these prime implicants later in the next slide because I'm running out of time. I have some other meeting also.
Okay, sir.
Yeah,
Sorry. Thank
yeah,
you, sir.
no problem. So yeah, maybe we can wrap up the session for today. If there is any further doubts, you can mail me anytime, and also I'll upload this video soon on the YouTube channel. And yeah, I mean, we can wrap up the session today. Thank you everyone for joining.